Hello and welcome. Invest Trigonometry for today. Today we're going to simplify the arcsine of 2x minus 1 minus 2 lots of the arcsine of the square root of x. So what does simplify means? Well, we'll see. We haven't got a clue at the moment what are we looking for. So let's get going with standard routines. So when we're having inverse trigonometric functions, the best thing is for that is actually to think of them as angles. So I'm going to call this bit here theta, and this bit here as phi. I prefer not to call phi two lots of the arcsine of the square root of x. It's going to be messier, okay? But you can, but it's not a sensible thing to do. All right, the first thing we need to do, if now we're going to call theta is the arcsine of 2x minus 1, then quite clearly, the sine of theta will be equal to 2x minus 1. And what else can we actually say? Well, what about theta? What values can theta take if we have the arcsine of 2x minus 1? Well, we can only get answers which are between minus pi over 2 and pi over 2. So these are some of the givens of facts, not givens, some of the facts about the inverse trig function, the arcsine. Now we're going to look at the arcsine of the square root of x. We called it phi. So phi is the arcsine of the square root of x, and therefore the sine of phi will be equal to the square root of x. And what can we tell about phi? What values can we actually get for our phi? Because we're putting in there only positive numbers and we have a valid output, we can only put x between 0 and positive 1. Otherwise, we're going to get, of course, we're not going to get real answers. Therefore, we can only get answers which are between 0 and pi over 2 for this particular one. We cannot go, of course, get inverse from the arcsine of the square root of x. We're going to possibly get a minus pi over 4, for example. Okay, so far so good. So the next thing is to put this information onto sort of standard triangles. And let's see how we're going to approach it. We're going to approach so you can actually see what I'm trying to get out of these triangles. I'm going to say eventually, I'm going to write it here and I'm going to rub it off. Theta minus 2 lots of phi is some kind of psi, where psi is going to be my simplification. I have no idea what form this will have. And then, in order to use sine theta and sine phi in all of this, I'm going to need to sine both sides of this equation. So it's going to look something like that. The sine of theta minus 2 phi is the sine of psi. And then, of course, I'm going to use my compound angle. So I'm going to need things such as the sine of theta, the sine of 2 phi. I'm going to need the cos of theta and the cos of 2 phi. So I need causes, really, for theta and phi. So I'm going to go to my little triangle. I'm going to draw one for the theta, first of all. That's the theta triangle. Mark one of the acute angles as theta and put the information. We got the sine of theta is 2x minus 1. So that means this side is 2x minus 1 opposite, and this is the hypotenuse. I need this side, Pythagoras, 1 minus 2x minus 1 all square rooted. It's going to give me 1 minus 4x squared plus 4x minus 1. I'm just removing the bracket at the same time. This will cancel. I'm going to get inside the square root 4x minus 4x squared, and it might be sensible to factorize a 4 out of the square root. So it's going to give me this quantity here. So that's the missing side. 2 over, not over, 2 square root of x minus x squared. And I'll get the cos in a minute. I'm going to write it on the side. I think the cos is in a second. Let me just do another triangle, and the triangle this time is for the phi. So this is my phi triangle. I should really mark the right angle, not that it's not obvious perhaps. Okay, sine phi is the square root of x, so this is my phi. Square root of x divided by 1, opposite of a hypotenuse, so that means that's the square root of 1 squared, which is 1 minus this quantity squared. So it's a lot nicer. It's 1 minus the square root of x. So from these two triangles, I obtain now additional information. I was going to put a line here to separate the two things, but conveniently now I have enough space to actually write my causes in there. So perhaps I should use that space there to write the cos of theta. the cos of theta is adjacent over hypotenuse. So that is 2 over x minus x squared. And the cos phi is, of course, the same quantity in analogy. So that's going to be actually that divided by 1, so square root of 1 minus x. So I've got all my bits and pieces. So I'm going to go with my original plan. So let's clear the board and see where this will get us. Okay, we're having now theta minus 2 lots of phi. So theta, oops, I'm writing 2. What's going through my head sometimes, I never know. Theta minus 2 phi is equal to some angle psi. God knows what it will be. This is it a constant angle? Is it something in terms of x? I'm expecting perhaps something in terms of x for that. And in order to use sine of theta, cos theta, sine of phi, and cos of phi, I want to perhaps, I can do the sines or coses, it doesn't really matter. I'm going to use this, I'm going to sine both sides of this equation. So the sine of theta minus 2 phi is equal to the sine of psi. Let's write it back to front. So the sine of psi is equal to compound angle, sine theta, cos 2 phi minus the other way around, cos theta, sine of 2 phi. I didn't take into account, I suppose, that I'm not going to get cos phi's and sines of 2 phi's, of phi's, I've got 2 phi's there. So I need to use more identity. This is not a problem, it's delaying me only marginally. Which identity to use for cos of 2 phi? Probably I'll use this one because it's easier. 2 cos squared phi minus 1 minus the cos of theta. Sine of 2 phi, I got no choice. 2 sine phi cos phi. And I'm ready to put some numbers in and start my simplifying. Okay, what do I get? The sine of psi is equal to sine of theta, 2x minus 1. That's the sine of theta. Times 2 cos squared of phi. The cos of phi is that. If I square it, I nicely lose the square root. So that's that. Minus the 1 that was already there. Minus cos theta. Cos theta is a mess, is 2. And then I go a square root x minus x squared. Times another 2 from there. Sine of phi. Sine of phi is the square root of x. And cos of phi is another square root. My God. All right, let's simplify that. Cross our fingers and hope for the best. So the sine of psi. What happens now with this bracket here? We got 2 minus 1 is 1 minus 2x. I got the negative of that. That's rather nice. I can factorize a minus and write it squared. I got a 2 times 2, so it's a minus 4. And that's also actually quite nice as well, because if you look what happens in there, here is this bracket, not this bracket, this radical here. But when I put these two radicals together, I get x minus x squared, which is exactly the same. I think this will simplify rather nicely. So let's have a look what we're getting. The sine of psi is equal to, I'm doing two things at once. We're in at enrichment now, so hopefully I don't have to show all the workings. All I'm doing is I'm pulling out of this particular bracket a minus to go at the front, and at the same time that will now swap into a 2x minus 1, so I can write it as 2x minus 1 all squared. Minus 4 lots of this quantity, but it's exactly the same square root, so I will lose completely the square root x minus x squared. So what do we get for that? The sine of psi is equal to, squaring this thing here is going to be minus 4x squared. That's going to be a minus, but that's going to be a plus now, so plus 4x. And then that's going to be a plus 1 minus 1. Minus 4x plus 4x squared. So goodbye, goodbye, gone, gone. So we found that in fact the sine of psi, not the psi, because the psi is what this thing simplifies to. Let's rub off and make some room. Let's have a little think about what we just got. Try to interpret it. We got that the sine of psi is -1. So let's write it, what we got, dot, 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 all these workings. Sine psi is equal to -1. What does that mean? It means your psi will be equal to, if we're getting a -1, what kind of numbers we'll be getting? We'll be getting things like -5 pi over 2. Sorry, it's not -5. I'll have to start from the middle, otherwise I cannot really subtract. I'll show you what I'm trying to do. I'm going to leave some space here. The inverse sine of -1 is, of course, -pi over 2. Okay, and if we move to the left, we're going to take off 2 pi. So it's going to be 2.5 negative. So it's -5 pi over 2. It was correct, actually. Okay, and then, I don't know, is it 9 pi over 2 after that? -9 pi over 2. And on the other side, it's going to be 3 pi over 2. And then 1.5 add 2 pi is 3.5, which is 7 pi over 2, etc., etc. So the question is, remember your your psi is this thing here. So far, we found that the arc sine of 2x minus 1 minus 2 lots of the arc sine of the square root of x is one of these numbers. Well, infinite set of numbers. So which one is it? It's not too difficult actually to find out which one it is. Remember in the beginning, I wrote those two lines. Let's put a little dot next to them. The theta is between -pi over 2, okay, and pi over 2. What is theta? Theta are called the arc sine, so that's this bit here. Now, your phi, which is just the arc sine of the square root of x, your phi is between 0 and, where is it, pi over 2. Therefore, if I double it first of all, because I have 2 phi there, where is it, -2 phi, it's going to be clearly between pi on the top end and 0. But if I multiply by -2, that will reverse the inequality, so it will be between -pi and 0. So if I want to say, okay, what is theta minus 2 phi? Theta minus 2 phi, so I'm going to write it here, theta minus 2 phi is a number which is between pi over 2 on the top end, it can be at most pi over 2, and at most, or at least, sorry, I beg your pardon, at least minus 3 pi over 2. So I have this constraint, so out of these numbers, the number that I'm looking for is between -3 pi over 2 and pi over 2. This is obviously above all these numbers. This is below. And therefore, the only quantity that matches this criteria is in fact negative pi over 2. Therefore, the simplification that I was asked to do, simplify this particular quantity, this, if I can find my orange pen, where is it? Orange pen, come back. That is in fact equal to negative pi over 2. And we should be happy that we've done it correctly with all the necessary precautions. I just want to show you a little trick that I will show you to one of my students. He wasn't actually aware of it. Depends how the question has been set. This is very, very useful. Okay. If I was to change the question and just a little bit of wording and say not simplify this, but I can say to as a question instead, show, okay, that the arc sine of 2x minus 1 minus 2 lots of the arc sine of the square root of x is in fact equal to pi over 2. Then the question, of course, you can do it exactly the same way. Sorry, I moved my board. I hope it's still in the same position for the video. You can still follow exactly the same method that you just seen there. But now there is an alternative which is far more powerful and far quicker to do. And I want to show you this very, very quickly. I don't know if you've seen this before. Okay. this is how it works. I'm trying to prove that, and I'm being told the answer is negative pi over 2. I'm going to say, okay, I'm going to define a function f of x. And this function f of x is in fact the arcsine of 2x minus 1 minus 2 lots of the arcsine. And I'm going to write the x to the half because it'll be easier to actually follow what I'm going to do next. I'm going to differentiate it. F dash of x, differentiation now of an arcsine. This will differentiate. I'm going to do the chain first. So it's a 2 at the top. And this is going to go square root of 1 minus bracket 2x minus 1 all squared, close square root. And then I proceed to differentiate this. So that's going to be a minus 2. I'm going to do the chain again first. So that's going to give me times, I'm writing times like an idiot, totally not an idiot, sorry. It's very late. What time is it? It's 11:15. So it's well past my bedtime, I guess. So that's the minus 2 that you're seeing in there. I'm going to do the chain first of all. A half x to the minus a half. And then that's going to be 1 minus this bit squared, which is 1 minus the square root of x. So I'm going to do a little bit of a tidy and see what happens. Let's look at this derivative now. 2. When I simplify that, I'm going to do it down here. 1 minus 4x squared minus 4x plus 1. The ones will cancel. 1 minus 1 cancels. And I'm going to get, of course, the square root of 4x, because I'm going to go positive, minus 4x squared. We've seen this expression earlier on when I was doing it in a different way. What about the second bit? The second bit, 2 times a half will cancel. That's that times that. And then this x to the minus a half, I can write as a square root at the bottom with, of course, a 1 minus x. So that's the second bit. And you can see what's happening in there. The things are going to cancel completely. Okay. Because, of course, I can pull out of the square root that 4. But when it comes out, it's going to be a 2. X minus, x squared there. 2. These 2's now will cancel. And of course this, if I rewrite it, it will be x minus x squared. And of course, what does that say? It says, you know this function you just defined, okay, this function of x, when you differentiate it, the answer is 0, and this is independent of x. So what does that actually mean? Well, what it means is this is a constant function. This particular function, f of x, is just a fixed number. The question is, what is it? Is that always equal to 4? So when we differentiate a 4, it becomes 0. Is it equal to 2? Is it equal to 1? What is it? Well, the simple answer is, in order to find what is it equal to, we substitute in there any number we want that we can evaluate, of course, which belongs in the domain of this function, because, of course, this particular function can only take numbers which are between, okay, for this, it has to be between 0 and 1. And for this one, in order to give us a minus 1, 2x minus 1 is equal to 1. It'll be 2x is equal to 2. And that's fine. And can we get a minus, if we put minus 1, 2x minus 1 is equal to minus 1, 2x is equal to 0. So in fact, the domain of this function is numbers between 0 and 1. So it works for both. I don't know if you follow what I've just done in there. I just done it just to kind of be happy in terms of a domain that everything is nice and sensible. Okay, so if you look at this now, I'm going to substitute in there any sensible number between 0 and 1 that will allow me to evaluate the constant value of this function. It doesn't matter. Let's put f of 0, for example. That will give me the arcsine of negative 1 minus 2 times the arcsine of the square root of 0, which is simply 0. The arcsine of 0 is 0. The arcsine of minus 1 is minus pi over 2. And therefore, we are done in about 3 lines if we had that answer. Because, of course, this, of course, wouldn't have worked if that, for example, simplified some other function of x. And since I mentioned that, just to show you, this is a nice opportunity to actually show you the proof of the identity. Sorry, Mum, lectures, I'm getting carried away. It's going to get a little bit longer than I planned. You know the identity cos squared theta plus sine squared theta is identically equal to 1. Of course, there's a little baby proofs that prove it based on right angle triangles, but that only works if your theta is a number between 0 and pi over 2. Okay, it doesn't work for anything else, because of course you can't just say, well, it works for every number. It's because it works for the angles of a right angle triangle. But this is now the proof for any number, okay, which is based on what you just saw. You define a function. I think this was asked to one of my students that went for a Cambridge interview a very, very long time ago. Define f of theta as the function cos squared theta plus sine squared theta. Okay, differentiate it. F dash of theta is, of course, minus 2 cos theta sine theta. And if you differentiate the sine squared, you're going to get plus 2 sine theta cos theta. And voila, we're getting gradient 0. So that means that your f of theta is a constant. And if it's a constant, it suffices to put any sensible number. So we can put f of 0. And if we do f of 0, we're going to get cos squared of 0 plus sine squared of 0. And of course, that is 1 squared plus 0 squared, which is 1. And therefore, I don't want to just be writing and rubbing off. That proves the result with the appropriate, obviously, finishing statement. Okay, I hope you enjoyed this particular lecture. And this is, of course, enrichment. The second bit, obviously, when I've done the differentiation, does involve knowing the differentiation of arcsine. But the first part, it does not require nothing but straight maths. Okay, I will see you very soon. I'm signing out now.